Hi students, in this module we will discuss about physical quantities, measurements and units. Learning objectives. Use of rulers and measuring cylinders to find a length or a volume. Measuring time intervals using clocks and digital timers. Determine an average value for a small distance and for a short interval of time by measuring multiples. Period of oscillation of a pendulum. Use of screw gauge to measure very small length. Why measurement is important in science? Science is not only a body of knowledge but also a way of knowing. Science begins by observing, measuring and collecting data. These data are analyzed to develop theory. The process is known as scientific method. Curiosity to know and understand this nature and natural phenomena is the beginning of discoveries and inventions in humankind. Everything starts with some questions in mind. Why or how it happened? How to make use of it? How to improve it? We arrive at an unconfirmed hypothesis on the basis of limited evidence as a starting point for further investigation. We collect more evidences, conduct experiments, and analyze data to arrive at a conclusion. A pseudoscience or speculation is set up to look for evidence that supports its claims. A science is set up to challenge its claims and look for evidence that might prove it false. Pseudoscience seeks confirmations and science seeks falsifications. A scientist is open for discussion and ready to accept new ideas based on evidences. Now we know why experiment and measuring physical quantities is important in science. Science is a collection of knowledge, or we can say it's an experimentally proved or mathematically proved knowledge. So experiment is important in science. A measuring instrument is used to measure a physical quantity. Measured physical quantities have a numerical magnitude and a unit. Here you can see some pictures of measuring instruments. A measuring cylinder is used to measure volume of liquid. A stopwatch is used to measure time. A meter ruler is used to measure length. And a digital weighing machine is used to measure mass. Volume, time, length, mass, these are all examples of physical quantities measured using a measuring instrument. The measured physical quantity consists of two parts, a numerical magnitude and a unit. Here 10 is the magnitude and centimeter is a unit. Here you can see different physical quantities and different units used to measure these physical quantities. Just like the way languages have developed in various parts of the world, many different systems of measurement have evolved. It is difficult to convert thousands of units into another. For this reason, scientists around the world use the Systeme International or SI system of units. There are 7 fundamental units. Here you can see 7 fundamental physical quantities and its units. To measure very small length, we can use picometer, angstrom, nanometer or millimeter. For day-to-day life, we can use millimeter, centimeter, meter and kilometer. To measure the distance between planets, we can use astronomical unit. And to find out the distance between stars, we can use light year. But if people use different units, then mathematical calculations and solving problems will be very difficult. and it will create a lot of problems when we send some things to other countries for trading. Also, it is very difficult. So we have these 7 fundamental units. The SI units of length is meter, and for mass it is kilogram, time, second, electric current, ampere, temperature, Kelvin, intensity of light, candela, and amount of substance, mole. Derived quantities are quantities that are calculated from 2 or more measurements. We can directly measure fundamental physical quantities, but we can't measure derived physical quantities. We can calculate derived physical quantities by combining fundamental quantities. You can see some derived physical quantities and its units here. Writing numbers as powers of 10 is a convenient way to express very large numbers and very small numbers. Instead of telling the powers of 10, we use some prefixes. Here tera is 10 to the power 12. Here number 12 is the power of 10. Measuring length using a meter ruler. Be careful to avoid parallax error. You can see the correct way to measure with a ruler. There may be some errors in measurement. Repeat measurement several times and take average to get more accurate result. Least count of an instrument is the smallest measurement that can be taken accurately with it. The least count of the instrument shown here is 1 millimeter. A zero error arises when the measuring instrument does not start from exactly 0. Here you can see a meter ruler with 0 error. You have to subtract 0 error from the measure reading to get correct reading. You can find the area of regular shapes using standard equations. Most of the time we have to convert centimeter square to meter square. 1 square centimeter equals 10 to the power minus 4 square meter. You can also find the volume of regular shapes using standard equations. 1 cubic centimeter is equal to 10 to the power minus 6 cubic meter. Volume of liquids. Measuring cylinders are used to measure volume of liquids. Liquids like water or alcohol shows concave meniscus. Liquids like mercury shows convex meniscus. For concave meniscus, we take lower reading. For convex meniscus, we take upper reading. Your eye should be along the meniscus line to avoid parallax error. Volume of irregular shaped dense objects. Displacement method. This method involves submerging the object in the water. Sink the object you want to measure completely in the water. The water rose from one level to a higher level when the object was submerged. The difference in reading is the volume of the object. If the object floats, attach a dense heavy item to it and continue on to measure the volume of both combined. After you write down that result, repeat this method with a heavy item alone to find its volume. Take the combined volume of both items, then subtract the heavy item's volume. Mass of object. The mass of an object is the measure of the amount of matter in it. The unit of mass is the kilogram. In the beam balance, The unknown mass on one side is balanced against known masses on the other side. In the lever balance, a system of levers act against the mass when it is placed in the pan. A direct reading is obtained from a digital top pan balance. Most of the time, we have to convert gram to kilogram. You can measure time using a stopwatch. You can see an experimental setup to find the period of oscillation of a simple pendulum. A simple pendulum consists of a long thread and a metal bob. In the absence of oscillation, the bob will be at the resting position O. We can pull the ball a very small distance from the resting position and release it to oscillate the pendulum. The distance from the resting position O to the maximum displacement of the bob is called the amplitude of oscillation. The distance OB or distance OA is called the amplitude of oscillation. If you release the bob from A, it reaches the point B and returns to the point A. Then we can say the pendulum completed one oscillation. The time taken for one complete oscillation is called period of oscillation. It is usually denoted by capital letter T. In some type of oscillations, the object makes several oscillations in 1 second. The number of oscillations in 1 second is called the frequency of oscillation. The total length from the rigid support to the center of the metal bob is called the length of the pendulum. You can place the metal bob between two wooden blocks to find the diameter and radius of the bob. You can also use vernier calipers or screw gauge to measure diameter. It is better to give a very small amplitude oscillation to get accurate result. You can also use a reference line or a needle to locate the position of bob. It is difficult to find the time for one oscillation. So we take the total time for 30 oscillations and divide that time by 30. It is not a good idea to take hundreds of oscillations because there will be damping and difficult to maintain oscillations in one plane for a long time. Vernier calipers and screw gauges. A vernier caliper can be used to measure inner and outer diameters of pipes, diameter of small cylinders or depth of small pipes. A screw gauge can be used to measure the diameter of thin wires or thickness of very thin metal plates. Significant figures. Every measurement of a quantity is an attempt to find its true value and is subject to errors arising from limitations of the apparatus and the experimenter. The number of figures, called significant figures, given for a measurement indicates how accurate we think it is, and more figures should not be given than is justified. For example, if a length measurement gives 114.8 millimeter, while the least count of instrument is 1 millimeter, then the first 3 digits are only reliable, so can be significant figures. Among these digits, there is uncertainty in the last digit, but it is also considered a significant figure. So the number of significant figures is 4. Number of significant figures equals number of digits which are certain plus one last digit which is uncertain. Or in another way, number of significant figures equals number of digits which are certain plus 1. Measurement using two different rulers. Here you can see ruler A and ruler B. For the first ruler, ruler A, 2.5 up to 2.5 is certain, but the last digit is not certain. So the total number of significant figures is the number of digits which are certain, so 2, and the last digit which is not certain. So the total number of significant figures is 3. Now coming to ruler B, 2 is certain and that 0.5, that 5 is not certain. So the number of significant figures is 2. The least count of vernier caliper is usually 0.1 millimeter and the least count of screw gauge is 0.01 millimeter. So instead of using meter ruler, if we use screw gauge or vernier caliper, we can write the answer with more number of significant figures. Rules to find significant figures. All non-zero numbers are significant. The number 24.4 has 3 significant figures. Zeros between two non-zero digits are significant. 3075 has 4 significant figures. Leading zeros are not significant. The number 0.54 has only 2 significant figures. 0.0032 also has 2 significant figures. Trailing zeros to the right of the decimal are significant. There are 4 significant figures in 92.00. Trailing zeros in a whole number with no decimal shown are not significant. Writing just 540 indicates that the zero is not significant and there are only 2 significant figures in this value. For a number in scientific notation, n times 10 to the power x, all digits comprising n are significant by the above rules. 10 and x are not significant. 5.02 times 10 to the power 4 has 3 significant figures for 5.02. Here 10 and 4 are not significant. You can find the number of significant figures in these numbers. Maybe up to 30 seconds you can take. Here is the answers. You can round these numbers into 3 significant figures. You can take up to 1 minute. Here is the answer and its explanation. Thank you. You can write your questions and suggestions in comment. If you like this video, you can subscribe and enable notifications.